let's come back now, and the last segment I diverged from not talking about the unit circle, so I'm going to give you a real quick, about 3 minutes on that. And then we're going to give you a very brief introduction and then to the trig functions so you can start seeing how the functions actually develop. So, very quick, brief practice on this. Let's say I was interested in the sine of 225 degrees. What you should be able to do now is not touch your calculator and not look at any notes. You should be able to do the following. Imagine your unit circle. You know that 225 should be, or is, 180 degrees plus 45. So mentally, what you should probably sketch, if this was a problem in your book, in your homework, you should probably sketch this and show this angle 225 degrees. It takes just a split second to sketch it. Then you can answer this question. It's one of the lengths that one of the 5 numbers we've talked about happens to be negative because it's pointing downward, square root of 2 over 2. Let's have you folks try one. Let's have you do, oh, and then what's the cosine of that angle?
Same.
Careful, it's not the same. Or is it?
Yeah.
Yes, it is.
Right on, it is. Okay, so it is. It's this x reading right here, negative. And the y reading is clearly negative as well. Okay? And if you took the ratio, and I have it upside down here, but if I took the ratio of the sine reading divided by the cosine reading, this would be this value divided by that would be 1. And that you can see clearly as a slope of 1 here. The tangent is then 1. Got it? Let's have you practice one item here, and you can sketch it right on the same sketch that you've made in your notes. Let me give you a 4th quadrant angle, and how about, let me do it in radians. Kind of fun. Okay? How about the cosine of 5 pi over 3? And I'll explain how I think my way into that after you've taken a moment to fiddle with it. Okay, how many of you have an answer? That's pretty good. By next Tuesday, I want you to be speedy. Okay, so practice over the weekend, please. Okay, try to be speedy with it. Not too speedy, though, because you don't want to make a mistake. So, the way I think into it is I go, man, this is getting pretty close to 2 pi, isn't it? So I'm thinking 6 pi over 3 is 2 pi. That takes me all the way around. If I back up 1/3 pi, I'm at 5 pi over 3. Right down here. Then I clearly can see that this y leg of that triangle is longer than that short leg. The short leg, the x leg there, is our cosine. Happens to be what? 1/2. And the sine, while we're at it? Negative square root of 3 over 2, isn't it? Longer than the half. It's easy once you get it. The tangent. What's the tangent? Be careful, I have these upside down here. I just did it with you in the previous segment.
1 over root 3. Or
Nope.
square root of 3.
This is bigger than 1, isn't it, in value? Steeper, right? So negative square root of 3. It's negative because it's down right. If you took this value and divided it by that value, the halves disappear. This divided by that, sorry I have it upside down here, this divided by this, you lose the 2's and you end up with minus radical 3. Okay. Enough said on the unit circle. Work on it, master it, and you'll be a very happy trig student. Okay. Now, the connection. How do we now start to build these functions? And you've had a glimpse of that previously. Here's my stick. If I take this, I'm trying to get in the camera. There we go. Okay, good. If I take this stick and I start rolling with it, moving through the angles, we talked about this previously. The sine is growing up towards 1, back down towards 0, the y readings, goes towards -1, and then comes back up from -1 to 0, right? Those y readings as we roll. And then they start repeating themselves. And it doesn't matter if I go negative angles or positive angles, it starts repeating itself after 2 pi radians. So, the very brief introduction to actually generate us a function let's address this too. Domain of sine theta. Is there any trouble for, if I pick some angle, is there any trouble finding the sine of the angle? No. No. It's an input, isn't it? Any angle can be your input, and you can compute a sine value. Right? So we have a domain of all real numbers. Right? There's our domain. The range of the sine function. How low can it go in value? -1. And how high? 1. -1 to 1. Inclusive for the range. Wouldn't those be the same for the cosine? Because doesn't the cosine on our unit circle, isn't that our x readings? And they vary between 1 down as low as -1 is -1, right? Okay, and everything in between. Okay, so that'd be our range on our cosine function. And the domain, any trouble picking angles in cosine? No, just like sine, no trouble. And we like to know this, don't we, in math? We like to know domain and range. It helps us set up a viewing window to see these graphs, right? Like you did in algebra. And so now we're just about ready to actually generate a function. So, how do you typically start when you have something new? You make yourself a table of values. So we could build ourselves a set of values of theta and the sine of theta, and we actually already know a bunch, don't we? And so instead of me building a table of values in the interest of time, why don't I just go ahead and give an angle and you tell me the sine's reading without your calculator, practicing the unit circle. So when angle theta is 0 degrees, what's the sine of theta? Use your mental image. Sine of theta, sine of 0 degrees is 0. Oh, that's a 0 of this function. It's an x-intercept. 90 degrees. 1. Right? Sine of 90 degrees. I'm plotting points here. I'm just imagining a table of values, and I'm picking the angle, and I'm asking you to think unit circle. 90 degrees, sine is 1. 180 degrees, back to 0. Back to 0. 270 degrees, -1. And then 360 degrees, 0 again. So what I've got going here is a top, a bottom, and some zeros. Okay, now watch this. with the stick again. When the angle starts here, and imagine the angle is changing uniformly. So it's moving, say, at a certain rotational rate. Isn't that point, right when we're near 0 degrees, isn't that lifting off really fast, just like a rocket, going almost like straight up? Right? Right? Now what happens up here near 90 degrees? As I roll the angle through 90, is the sine reading changing much? No, it's kind of hovering up here near 1, isn't it? Doesn't it hover up here near 1 in value? Whereas over here, near 0 degrees, it is changing rapidly, from 0 rising quickly, right? So that idea shows up here. This thing takes off kind of quickly here at 0 degrees, and then when you get up here near 90 degrees, it's actually hovering there near 1. And finally, watch this, at 30 degrees, if I split 90 into thirds, right? And then right smack in the middle is 45, right? We know those numbers, don't we? At 30, we're already a halfway up. You see that? We're halfway up to 1 at 30 degrees. And then at 45, it's at square root of 0.707, square root of 2 over 2. 70% of the way up, 0.707. And then when you're at 60 degrees, you're up at 0.866, 86% of the way. And so you get a nice smooth graph looking like this. And doesn't it go down the same way it came up? Symmetrically? So once you've done a little thinking here in this first quadrant of angles, between 0 and 90 degrees, we can just build the rest of this thing, and we've got ourselves our first trigonometric function. This is exciting. Isn't cosine going to look similar? Not exactly the same, but kind of similar. Think about the behavior of those numbers. Okay, cool. That's a good introduction to it. Study up over the weekend. Don't forget there's a quiz. That's the end of the session. Don't forget there's a 25-point quiz. It's not due till next Wednesday night. I sent you folks